Hello, in this video, we'll be addressing some common mistakes made by students in complex numbers. One of such mistakes is the one before us, where we have the powers of imaginary number, I to power n, which we know is the same thing as I to power r, where r is the remainder when we divide n by 4. Now, this is true for imaginary powers, but when we have a complex number, general complex number in the form of a plus bi, where a is the real part and b is the imaginary part. Is this still true? Do we say the power of a complex number? We also can use this formula. Now, this is not true, and we'll be addressing that shortly. Now, let's start with some common mistakes. So, simpler ones. So, let's take this first one. Now, we know that the roots, if you have of, let's say, minus 5. Now, this is not the same as what? As 5i. What do we know about I? We know that I is what? Is the square root of minus 1. So, if we have the root of minus 5, we can see it as what? We can see it as the root of minus 1 and 5, right? Times 5. Which this is simply root of 5, then what? Then I. Now, this is correct. Another mistake, number 2, is when we try to do this. I've seen students make this as well. Root of minus 2, for example, multiply by root of minus 3. This is not, you see, these are even roots and negative numbers. So this is the square root of negative numbers. So it's imaginary, both are imaginary. Now, this is not the same as this. This is not true. But what is true is this one. If you have two imaginary numbers like this, you can write this as what? Just apply this first part here. This will become root 2i. Multiply. This will become root 3i. Then now we can combine 2 and 3 in the same radical. Then I square. So I square is minus 1. So you have minus root of 6. This is true because we know that I square from here, we know I square is minus 1. Okay. Then another one is this one. When we are dealing with what? When we are dealing with, let's say, odd roots. For example, we have the cube root of minus 8. Now, the cube root of minus 8 is not an imaginary number. It's a real number. So this is not the same as 2i, but rather the cube root of minus 8 is what? It's just minus 2. And this applies to other odd roots. For example, okay, let's even say still maintain 3, cube root of minus 27. This is not a complex number. This is just minus 3. So you're only going to have an imaginary number. I mean, you're going to have an imaginary number if you are dealing with an even root. But if your root, I mean, the index is what? If the index is odd and you have a negative number, you should still get but a real number, not an imaginary number. Okay, so let's move to one more interesting one is this one. Let's talk about powers of imaginary number. Okay. And we know we said in, where n is any positive integer, we said is the same thing as ir. And what is r? We said r is the what? Is the remainder when we divide n by what? By 4. For example, if we want to find I to power 7, we say this is just going to be I to power what? To power 3, right? Why is it to power 3? Because 7 divided by 4 is going to be 1. Then you have remainder 3. So this is what's now the same thing as I square times I. And we know that I square is minus 1. So this is just minus I. So I to power 7 is just minus I. Okay. So another example is what is if you have, let's say, I to power 21. 21 divided by 4 is 5 remainder 1. So this is just I to power 1, right? Okay, this is good. Now, this is what I've seen some students, I've seen from some student. For example, if you have 1 minus I, let's even make it to power 3. Now, I've seen students do this. They say this is the same thing as 1 minus what's I to power 3. I mean, they try to distribute this 3 so that it will be 1 to power 3 minus I to power 3. And they say this is the same thing as 1 minus what I to power 3 is just minus I. So this is 1 plus I. Now, this is not correct. You cannot distribute the powers. This is not, you cannot say 1 to power 3 minus I to power 3. This is not true. So what is true if you're dealing with situation like this? It's simply remember your binomial expansion is still valid here, right? So what will this be? This will simply be 1, then what? 1 cube. The coefficient here should be 3. Then the power of 1 will reduce by 1. Then I will take the power 1. Then you have plus. The coefficient here will become still 3 because we're dealing with power 3s. And here you have 1. Then the power of I will increase to become 2. Then you'll have minus what? Now I think it will be I to power 3. So what am I using here? We're using this one. A minus B to power 3 is what? Is A cubed minus 3A squared B plus 3 A B squared, right? Then I think minus what? B cubed. So this is what I try to use here. So let's remove this. And what will this be? This is 1 minus what? Here will give us just 3I. And here will become, this is I squared. So this will be minus 3. And here we have minus, this is I cube. We know I cube is the same thing as what? Is the same thing as minus I. So this is minus I here. So we'll have 1 minus 3I minus 3, then plus I. So this is 1 minus 3, which will be minus 2. And you have minus 3I plus I, which will be minus 3I plus I. So this will be minus 2I, right? Yes. Okay. Then what next? If we look at this, so this is what it should be. So if you have 1 minus I to power 3, it should be this much. Okay. Now, what about if you have higher powers? It's still, if you have higher powers like 4, 5, 6. Okay, if you have, like, let's say you have up to 4, right? If you have I to power 4, then you should use still the Pascal triangle, and just similar way, but the coefficients now will change if you use your Pascal triangle to get the coefficient. Okay. Then now, let's look at if the power becomes so high, like say something like you are looking for what? For 1 minus I, let's even say to power 7, for instance. Now, can we say that this is the same thing as dividing by 4, so that this becomes 1 minus I to power 3? So what happened here? You divide what? 7 by 4 and you say the remainder is 3. No, this is not true. So you cannot apply this rule, I to power n to I to power 3. You cannot apply it unless the what? The imaginary, unless the real part of that complex number is what? Is 0. So here, the real part is what? Is 1. The real part is not 0. So you cannot apply this one. So please take note. We only apply this when we are dealing with what? An imaginary number. It means the real part is what? You know, every complex number is in the form of a plus bi, right? So if the real part is 0 and you have only this part, and you have only the bi, it's fine, because you can take the power, for example, power 75. This will just be what? B to power 75, then you have I to power 75. Then you can apply that rule here. But in a situation where you don't have, the real part is not 0, then don't apply this rule here. Okay? So what am I saying? In general, don't do this. So if you have a complex number z, where z is equals to what? A plus what? Bi. So to power n is not the same thing as what? A plus bi, then you put power r. No, this is not true. Now, there is how to handle this one. There's how to do it, but it's above the level of this video in complex analysis. We call it De Morgan's theorem. So you don't need this. Anytime you have a complex number, let's say you have a complex number z, and you want to find the power to power n, it's simply the same as what? It's simply the same as r to power n. Then you have what we call cosine n theta plus what? I sine n what? Theta. Now this, I'll tell you what r is. R is called what we call the modulus of the complex number, and theta is called the argument. So this is what we call the De Morgan's theorem. De Morgan's, right? Things, yeah. Theorem. So don't worry about this. You don't need this for now. You will meet it in future. Now, so now this brings us to the question. Then how can we solve something like this? For example, you might have seen this type of question: 1 minus what? I over what? 1 plus I, right? To power 75. Now, to solve this, if you try to do this one, This is what some of my students did. They splitted this and also this one, right? No, this is what they did actually. Let me do it this way. Many students did this. Now they divided this by what? By 4 as usual, and they arrive at this one, and the remainder here 3. And from here they took this 3 inside, so it became 1 to power 3 minus what? I to power 3. Then the same thing here, 1 to power 3 plus I to power 3. And this is now became 1. This now, it's, okay, they now applied the rule here. So, this is easy already. So this is like minus I, right? And here 1 plus what? Minus I. Now, this is not true. This, especially this statement from here to here, we cannot do this. So here, what have they done? They've applied the powers of imaginary number to a complex number. This complex number here, you are not sure yet if the what? The real part is what? Is 0. Okay? So, because it's even easier, because here is what? Is 2. But if we make it, here is 1. If we make here to be 2 and here to be 2, it becomes even more complicated. So to handle this type of question, at this level, this is what you should do. Deal with inside first. You try to rationalize what is inside. So this will be 1 minus I over 1 plus I. You can multiply it with 1 minus I and 1 minus I. You're rationalizing with what? The conjugates of the denominator. And so you leave this 75 here. Then finish what is inside. If you do this, this will give us 1 times 1, which will be 1. 1 times I, this is minus I, this is minus I. Then minus I times minus I, it becomes plus what? I square. And the denominator is just a difference of 2 squares. So this is 1 square minus what? I square. Then all, you still have your power 75. So now, if you look at this, this will become 1 minus what? 2I, and this will be minus 1 over, and here is what would just be 1 plus I square. So this becomes 1 plus 1. And now we still have power 75. Okay, so this will go with this, and you have what? Minus 2I over what? Over 2. Then now to power 75. So 2 will cancel 2, so you have minus I to power 75. Now, since the power is odd, minus can come outside, so you just have minus I to 75. Now you can see it's nice. So we are now back to what? Where we can use our rule, because here it's purely imaginary. The real part is what? It's 0. So here we can now we can divide by 4. So this is minus, and this will be I to power what now? I to power 3, yes? And this, we know this will be minus, and I to power 3 is what? Is a minus I. So everything becomes what? Just I. Okay? Now, what is the lesson here? The lesson here is, before you can apply this power, the power rule for imaginary number, you should make sure that what? That the real part of that complex number is 0. Now, if the real part is not 0 and you have something like this, first of all, rationalize it before you apply it. But in general, the power of an imaginary number is not the same as the power of a complex number. So if you have IR is the same thing as IR. But if you have a complex number Z, which is equals to what? In general, in standard form, A plus BI, and you want to find Z to power N, it's not the same as what? Z to power R. So take note of this. I hope this have clarified some misconception. Right? Thank you for watching.